Good day, Olivarians! Welcome to Module 6 of NS001 Earth Science. I'm here again, Sir Jason Lumagas. I will be your instructor for this lesson. Our topic for today is about rocks and the rock cycle. So let's begin. After studying this module, you are expected to first describe the different processes happening within the rock cycle. Second, you should also be able to explain the formation of igneous, sedimentary, and metamorphic rocks. Third, you should also be able to distinguish the three types of rocks based on their texture and composition. And lastly, you are also expected to be able to classify rocks into igneous, sedimentary, and metamorphic. Let's first define what are rocks. In your previous lesson, you have learned about the general characteristics of minerals, including its physical and chemical properties, as well as its types. But how do these minerals differ to rocks? Rocks are naturally occurring, meaning they are naturally present or existing in our environment, just like minerals. Rocks are consolidated materials consisting of one or more minerals or solid materials such as organic matter, rock fragments, or natural glass. When we say organic matter, it can be either any parts or materials coming from an organism, which can be a plant, an animal, or even from us humans. When we say natural glass, it is a type of rock that is formed in the Earth's crust, which has a glassy texture. Aside from that, rocks can have different colors. They may also vary in terms of size of individual grains that we can see on the rock itself, and even on their mineral composition, just like what you see in the background picture. And generally, when we say petrology, it refers to the study of Earth that deals with the origin, structure, occurrence, and as well as history of the rocks. But how rocks are formed? Do you have any idea? Where did they come from? What is rock cycle? Basically, it helps us understand the origin of the three basic types of rocks, which are igneous rocks, the sedimentary rocks, and the metamorphic rocks. The rock cycle is a dynamic cycle of processes and products wherein we can see how and where rocks are formed, changed, broken, and melted. These changes in rocks occur both on Earth's surface, where we are living, and underneath or underground. How does the rock cycle work? It is the movement of tectonic plates that makes the rock cycle happen. Remember that these tectonic plates are pieces of Earth's crust in the uppermost mantle, which is collectively called as the lithosphere. This lithosphere is situated on top of the asthenosphere, which is a soft and weak spot containing the partially molten rocks that makes the plates to move slowly. Hot magma coming from the mantle, as you can see in the illustration, can go up to the crust, wherein it can cool down to form igneous rocks. This magma that goes up to the crust can solidify either inside the crust, wherein it undergoes slow cooling that makes granite or granitic rocks, or it can also cool down or solidify on the Earth's surface that undergoes fast cooling that makes basalt or basaltic rocks. The rock cycle involves different processes and products. Let's begin with the different processes. The melting of mantle rocks will result into the formation of magma. This magma will later undergo crystallization or cooling and solidification, which will create igneous rocks. These rocks can be pushed up into the surface of Earth by a process called uplift. From here, the surface rocks are exposed to weathering and erosion, which makes sediments. These sediments can be transported either by strong winds, running water, or glacier to another place where it can be deposited. That process is what we call deposition. As time goes by or over time, more sediments can be accumulated to this new place, which later undergo a new process called lithification. Lithification involves compaction and cementation. This process will later create sedimentary rocks. And the last process is metamorphism, when either a sedimentary rock or igneous rock, or also can be a metamorphic rock, when they are exposed to too much heat and pressure, it can later form a new type of rock, which is a metamorphic rock. Here are other illustrations of the rock cycle for you to see clearly what happens on each process. In the first illustration, we can see that a metamorphic rock can melt and form into a new magma. In the second illustration, we can see the cooling and solidification of magma through the process called crystallization. Next shows about weathering and erosion, wherein rocks are eroded and washed away by wind and water, producing sediments. And the last illustration shows about the deposition and lithification processes, forming sedimentary rocks. This is the whole picture of the rock cycle, wherein we can see the different locations of each type of rocks. Alright? Let's begin in this yellow color, wherein we can usually found metamorphic rocks. But this type of rocks is usually found either deep in Earth's crust or at plate boundaries where tectonic plates collide. Okay? Next, here in this red color are igneous rocks, which are found either inside the volcanoes or outside the volcanoes. Okay? And next to that, in this area in green color at the Earth's surface is where we usually see sedimentary rocks. Okay, this is the type of rocks that most of us usually see. Okay, apart from knowing the locations of each type of rocks, always remember that the path of rocks in the rock cycle may vary. Okay, like for example, let's use this type of rock, this igneous intrusive rock, as an example. Okay, this igneous intrusive rock may remain deeply buried inside the volcano instead of being exposed to weathering and erosion. But when this rock is exposed to too much pressure and heat, they will transform, or they can be transformed into metamorphic rocks. Okay? In connection to that, sedimentary rocks and metamorphic rocks do not always remain buried as well. Alright? Because the overlying layers, for example, on this area, may be eroded causing the buried rocks to be exposed to weathering. So if that happens, the rocks are affected by the physical and chemical processes of weathering, which eventually will produce sediments. That's it. Now let's talk about the three classification of rocks. First, we have the igneous rock. Second, we have the sedimentary rock. And the last one, we have the metamorphic rock. For the igneous rock, we have here the scoria that exhibits vesicles. For sedimentary rock, we have here the dolomite as an example. Dolomite is formed when limestone is exposed in a groundwater containing magnesium. Next, we have the metamorphic rock. We have here gneiss, which is an example of foliated metamorphic rock. Now let's talk about each type of rocks. Igneous rocks are formed by fire. The term igneous comes from the Latin word ignis, meaning fire. The picture behind is an example of lava flows from Mount Pinatubo, which will eventually form igneous rocks when cooled. It is also important that we understand how magma is formed. There are three main ways to form magma. Magma forms from partial melting of mantle rocks, so meaning it is not totally liquid. It happens in the deeper parts of the Earth's crust and in the uppermost parts of the mantle because of changes in temperature, pressure, and addition of fluids that cause magma to form. Most rocks melt between 800 to 1000 degrees Celsius. The illustration on the side shows how molten rocks rise up to the crust. Remember as well that increasing pressure raises the melting point. On the other hand, increasing water content lowers the melting point. In terms of the composition of magma, it contains mostly of a very hot liquid rock matter, minerals, and dissolved gas. Its temperature varies from 600 degrees Celsius to 1000 degrees Celsius depending on its composition and the depths at which it forms. The principal elements that we can see or we can find in magma are oxygen, silicon, aluminum, calcium, sodium, potassium, iron, and magnesium. But the primary constituent or composition of magma is silica, which is about 45 to 75% by mass. The amount of silica, temperature, and gas content control the viscosity of the magma. When we say viscosity, it refers to the resistance of the magma to flow. In terms of the crystallization of magma, it is also important to know about the cooling time of magma because the cooling time influences the crystal size. This is the reason why we have large rocks and small rocks. Okay? The longer cooling time, the larger crystals will be formed. On the other hand, the shorter cooling time, the smaller crystals that will be formed. How are igneous rocks formed? It is through magma or lava. This magma or lava may undergo crystallization, which is cooling and solidification, that will eventually form intrusive and extrusive igneous rocks. Speaking of magma and lava, are they the same thing or they differ to each other? Magma and lava are both molten rocks. They might be similar in terms of their composition, but they differ in terms of their location. Magma is the molten rock that is generated beneath the Earth's surface, while lava is the molten rock that reaches the Earth's surface. Okay? In short, lava is produced from magma, which is now in direct contact with air and water. Lava is the one that comes out from the volcano. So that is how igneous rocks are being formed. Let's now talk about how each type of igneous rocks can form. There are actually three ways in which this type of rock can form. The first one is below the surface of Earth, which is from the slowly cooling magma, which will result in the formation of intrusive igneous rocks, or also known as the plutonic rocks. As the name suggests, plutonic, it is derived from the word Pluto, which is referring to the Roman god of the lower world. It is interesting to know that igneous intrusive rocks are the first type of rock that can be formed. That's why they are also known as the primary rocks. Second is we have the type of rocks that can be formed on the surface of Earth, which is from the rapidly cooling of lava. Again, when we say lava, it is the molten rock that reaches the surface of Earth. This will result in the formation of extrusive igneous rocks, or also known as the volcanic rocks. Volcanic rocks derive from the word Vulcan, which is referring to the Roman god of fire. Originally, we only have two types of igneous rocks based on how they were formed. But there is actually another type of igneous rocks. Alright? That is the type of rocks that are also formed on the surface of Earth. But the difference of this type of rock is that this is a consolidation of particle erupted by explosive volcanic activity, just like what you see in the illustration. This is called the pyroclastic igneous rocks that resulted in particles that come together via lithification. In short, these pyroclastic igneous rocks are combination of igneous and sedimentary processes. So again, to sum it up, we have three igneous rocks: the intrusive, extrusive, and the pyroclastic igneous rocks. Another way to identify igneous rocks is through their texture. Texture is the overall appearance of the rock based on the size, shape, and arrangement of mineral grains and other constituents in a rock. The texture of igneous rocks may exhibit a crystalline texture or pyroclastic texture. Crystalline texture happens when they form from cooled magma or lava, which may exhibit a coarse grain or a fine grain texture. When we say coarse grain, the rock has a rough texture. We can clearly see the mineral grains on the rock. On the other hand, when we say fine grain, the texture of the rock is smooth and we cannot almost see any traces of its mineral grains. Okay? And then pyroclastic texture happens when they are made of consolidated eruption products such as volcanic ash. So now let's talk about the texture of intrusive igneous rocks or plutonic rocks. This type of rock may specifically exhibit texture such as pegmatitic texture, which has medium coarse grain, which is about 1 to 5 millimeter. And then they may also exhibit a paneritic texture, which has a coarse grain texture, which is about greater than 5 millimeter. As an example, we have here the diorite and the pegmatite. Okay, as you can see in the picture, we can see different colors, right? That's because of their mineral composition. Those are mineral grains. Remember that the cooling time in the earth surface below is very slowly, okay, which makes a very large crystals on the rock. So now let's talk about the textures that we can see in extrusive or volcanic rocks, which specifically exhibit textures such as aphanitic, which has a very fine grain to fine grained texture, which is about less than 1 millimeter. As an example, we have here rhyolite. So we can see that the mineral grains on the rock is very fine, and it also has a smooth texture. And next we have the glassy texture, which is much smoother than the aphanitic texture. Obsidian has a smooth texture. It's very visible on the picture. And then we also have vesicular type of extrusive volcanic rock. Vesicular texture has vesicles on its rock. Okay, this is an example of pumice. And then extrusive rocks may also exhibit propyritic texture, which may show at least two distinct crystal sizes. This is an example of andesite. And then the last one, the pyroclastic rocks, may exhibit textures such as pyroclastic. We have an example here of tough beryllium. Again, these are the different textures of igneous rocks. Here are specific examples of igneous rocks. Remember that we have three types of igneous rocks. First, we have the intrusive or plutonic rocks, which are rocks that are made or formed beneath the surface of Earth. Next, extrusive or volcanic rocks, which are rocks that are formed on the surface of Earth. And the pyroclastic rocks, which are also formed on the surface of Earth but contains consolidated materials from volcanic eruption. The common example of intrusive igneous rocks are diorite, pegmatite, gabbro, and the granite. Among the four, the granite is the most common type of intrusive igneous rocks. Generally, they exhibit a coarse grain texture. For the extrusive volcanic rocks, the common examples are andesite, which has a fine texture, basalt, which is usually in black color, which is also the common extrusive igneous rock. We also have obsidian, which has a glassy texture, and then the pumice. In pumice, we can see different pore spaces here. This is called vesicles. This is made due to the gas bubbles that were trapped during its solidification. And then the last one, the common pyroclastic rocks are the tuff and the volcanic breccia. So these are again the examples of igneous rocks. Igneous rocks can also be classified using their mineral composition. This mineral composition of igneous rocks, we can see this in the Bowen's reaction series. This Bowen's reaction series has two sequences: the continuous sequence on the right side and the discontinuous branch on the left side. In this reaction series, we can see the order and assembly of minerals as they crystallize when the temperature of magma decreases. Okay, on the left side, the discontinuous branch, if the magma reaches 1400 degrees Celsius, the mineral olivine will be formed. And then when the temperature of magma drops, another type of mineral will be formed, which is the pyroxene. And then eventually, if the temperature of magma continues to drop, another type of mineral will be formed as well, which is next is amphibole until biotite will be produced. This biotite will be the last to be produced in this sequence, but there can be more if the magma has not yet completely solidified. On the right side, in the continuous branch, as we can see here, only the plagioclase is the mineral that contains the calcium-rich and sodium-rich. It contains 50% calcium and 50% sodium. Alright? What happens here, it goes the same way with the discontinuous branch. Alright? Because of the temperature, this plagioclase can produce another type of mineral, which are orthoclase, muscovite, and the quartz. So always remember when we say mafic, okay, it contains higher iron and magnesium. Felsic, on the other hand, contains lower iron and magnesium. So this is the mineral composition of igneous rocks. In connection to the mineral composition, the color index of igneous rocks can also be used to identify the composition of this type of rocks. It depends on the minerals present and the size of the minerals. In this continuum, we can see the general composition of rocks, specifically the igneous. We have here the ultramafic, mafic, intermediate, and then the felsic. We can distinguish this according to how light or dark the color of rock is. This coloration depends on how much minerals they contain. For ultramafic and mafic composition, they exhibit dark colors, which can either be black or brown. That indicates poor content of silica but rich in iron and magnesium. Next, we have the intermediate composition that exhibits intermediate colors, which can be gray or consisting of equal parts of dark and light mineral. And the last one, we have the felsic composition that exhibits light color. This can be in white color, light gray, tan, and pink. Again, these are the general composition of rocks, specifically the igneous. Ultramafic is the darkest. We also have the mafic, intermediate, and then the felsic, which is the lightest color. Did you know that igneous rocks are the most abundant type of rocks we can see in the Earth's crust? The second main type of rocks are sedimentary rocks. Sedimentary rocks are compacted and cemented sediments. The term sedimentary, as the name suggests, was derived from the Latin word sedimentum, which means settling, as these sediments will eventually be deposited and settle until they are transformed into a sedimentary rock. The picture that you can see at the background is an example of sedimentary rock, which is a shale that can be found in Thailand. How are sedimentary rocks formed? This type of rock forms from sediments. These sediments undergo a series of processes which include weathering, erosion, transportation, deposition, and lithification. Lithification involves two other processes which include compaction and cementation. This series of sedimentary processes will result to the formation of sedimentary rocks. Speaking of sediments or sedimentary rocks, what are sediments? Sediment is a collective name referring to rock particles, that may also be composed of mineral fragments and organic material or minerals that precipitate from solution. With regards to the series of sedimentary processes, what are these processes? What's the difference on each process? Let's define each process. Weathering, when we say weathering, it refers to the physical integration and chemical decomposition that causes rocks to change or break down upon exposure to physical, chemical, and biological processes. The next process is erosion. Okay? Erosion refers to the physical removal of weathered materials from the original location. It can be transported away by any natural agent. Next, we have the transportation, which refers to the movement of rock fragments from one place to another. Transportation may happen, okay, or the rock fragments may be transported either by strong winds, water, or glaciers. Next, these fragments will undergo deposition. Deposition is the dropping of sediments to a new place. The last part in the series of sedimentary processes is the lithification. Lithification is a group of processes by which sediments or the rock fragments are converted into consolidated rocks. When we say consolidated rocks, the rocks combined already, forming a new type of rock. This process involves two other processes. The first one is compaction, which happens when the layers of sediment build up. The pressure on the lower layers increases over time. And then the last process in the lithification is cementation. This process happens when particles of sediments begin to stick together. They are cemented together by clay or by minerals like silica or calcite present on that area. Here's an illustration wherein we can see compaction and cementation. So through time, the rock fragments that are deposited on this place will increase in pressure that eventually will result in the formation of a new type of rock, which is a sedimentary rock which has different layers or which can have different layers. Just like the igneous rocks, sedimentary rocks can form in three main ways. The first one is from the cementation of sediments that have been deposited, buried, and compacted over a long period of time. This will result into the formation of clastic sedimentary rock, or meaning a mechanically formed type of rock. As an example, we have here the shale. Next is from the dissolved materials that precipitate from solution. Remember that exposure of rocks to water and oxygen can lead to chemical changes in rocks, which will result into the formation of chemical sedimentary rocks. We have here a rock salt as an example of chemical sedimentary rocks. This rock salt is formed from evaporation of ocean or a saline lake water. This rock salt is also called as halite, which is also used as a seasoning for food. The last one is from the compaction and cementation of plant and or animal remains, which will result on the formation of organic sedimentary rocks, or called as bioclast. We have here the coquina, okay, or coquina, which is a poorly cemented limestone that is composed of mainly broken shell debris. Here are the common examples of sedimentary rocks. For the clastic sedimentary rocks, the common examples are breccia, sandstone, siltstone, and the shale. For the chemical sedimentary rocks, the common examples include flint, iron ore, chert, and rock salt. And lastly, we have the organic sedimentary rocks. The common examples of this type of rock include coal, limestone, chalk, and diatomite. Again, these are the common examples of sedimentary rocks. These three are the three types of sedimentary rocks: the clastic sedimentary rocks, the chemical sedimentary rocks, and the organic sedimentary rocks. In terms of texture of sedimentary rocks, the clastic sedimentary rocks may exhibit a coarse grain texture. As an example, we have breccia. It may also exhibit a medium grain texture. Sandstone, as an example. It may also exhibit a fine grain texture. Siltstone, as an example. And then, clastic sedimentary rocks may also exhibit a very fine grain texture. As an example, we have the shale. The third main type of rocks are the metamorphic rocks. This type of rock is a new rock that is formed from old ones. The word metamorphism was derived from the Greek words meta, which means change, and morphe, which means form. It occurs at temperatures higher than 200 degrees Celsius and before melting point of the rock, and at pressures higher than 300 MPa or megapascal pressure unit. The picture behind is an example of Lewisian gneiss, which is found in the Outer Hebrides of Scotland. How are metamorphic rocks formed? Unlike the sedimentary rocks and igneous rocks, metamorphic rocks may form from any pre-existing or parent rocks, which can be an igneous rock, a sedimentary rock, or even a metamorphic rock. This may happen when these parent rocks are exposed to extreme heat and pressure, or can also be due to chemical active fluids that may cause a mineralogical, chemical, and structural changes to these parent rocks, which eventually will result into the formation of a new type of rock, which are metamorphic rocks. This type of rocks have two major types, depending on which factor causes the alteration of the parent rocks. First type is the foliated metamorphic rocks, or also known as regional metamorphism. These foliated metamorphic rocks are formed when the dominant altering factor is pressure, usually due to tectonic activity. The second type is non-foliated metamorphic rock, or also known as contact metamorphism. This type of rocks are formed when the dominant altering factor is heat, usually due to direct contact between an older rock material and an intruding body of magma. Now let's talk about the different examples and textures of foliated metamorphic rocks. When we say foliated or foliation, it means that the rocks have bonded or layered appearance. This type of metamorphic rocks may exhibit a slaty texture. We have here the slate as an example. It may also exhibit a phylitic texture, which we can see in a phyllite. It may also exhibit a schistous texture, which may see in a schist. And lastly, it may also exhibit a gneissic texture that we can see in a gneiss. So again, these are the common textures and examples of foliated metamorphic rocks. As we can see on each picture, we can see the different foliation. Okay? For the slate, the minerals are microscopic, meaning the rock may not appear foliated to our naked eye. In phyllite, that exhibits phylitic texture, the minerals are barely visible to the naked eye. So, their alignment results in an obvious but not clearly defined foliation. In schist, which exhibits a schistous texture, the minerals are visible to the naked eye, and their layering is more distinct as we can see in the photo. And lastly, in a gneiss, the minerals are much visible compared to the other textures. And the foliation is very visible. So again, we have the slate, the phyllite, the schist, and the gneiss as examples of foliated metamorphic rocks. So again, this type of texture are simply brought about by pressure. The platy or elongated minerals that we can see in these rocks align themselves parallel to the axis of pressure that they experience. That's why they have layered or banded appearance, or also called as foliation. Now let's talk about non-foliated metamorphic rocks. This type of metamorphic rocks exhibit a crystalline texture but non-foliated, meaning they don't have any layering, bonding, or alignment. Non-foliated metamorphic rocks may exhibit a granoblastic texture and a hornfels-like texture. When we say granoblastic texture, this is an equigranular texture in which crystals have well-sutured planar boundaries. As an example, we have first the amphibolite. We also have the marble, which is the common example of non-foliated metamorphic rocks. We also have here the quartzite. So these are the example of non-foliated metamorphic rocks that exhibit granoblastic texture. And then the second one, the hornfels-like texture, we can see this texture in hornfels. Again, these are the examples of non-foliated metamorphic rocks. Here's an example of metamorphism wherein we can see a limestone that is changed into a marble. Here, the parent rock is the limestone, and then the daughter rock or the new form rock is the marble. Here's another example of metamorphism that represents a metamorphic continuum that shows an increasing metamorphism, meaning there is an increasing pressure and temperature experienced by each type of rocks. Okay, so in this illustration we can see 5 types of rocks, right? Among the 5 examples, the parent rock here or the pre-existing rock here is the shale. This shale is a sedimentary rock. When exposed to high temperature and heat, it may change into a metamorphic rock, which is a slate. This slate, when also exposed to high heat and temperature, or heat or temperature and pressure, it may also undergo another change, okay, into another type of rock, which is the phyllite. When this phyllite also experience high temperature and pressure, it may change again into another type of metamorphic rock, which is the schist. And then, due to the increasing temperature and pressure, it may also change again into another type of rock, which is the gneiss. Again, this is an example of metamorphism. The slate, the phyllite, the schist, and the gneiss are examples of foliated metamorphic rocks. Aside from knowing the rock cycle, the formation of rock cycle, the texture and composition of the three main types of rocks, it is also interesting to know the different uses of each type of rocks. For igneous rocks, generally, they can be used to make statues, bricks, and stones. Some common examples of igneous rocks are granite and diorite, which can be used for facades of buildings. We have here an example, the Marshall College that can be found in Scotland. This building is made up of granite. This is actually the largest granite building in the world. We also have the andesite, which can be used in the construction field to make tiles. Here's an illustration. Next, we have the pumice, which can be used to remove dead skin from people's feet. Here's an illustration of a pumice rock. But if you have diabetes, it is not advisable for you to use pumice to remove dead skin. Next, we have the obsidian, which has a glassy texture that can be used for ornaments and making cutting tools. Here are examples of obsidian that is used as ornament and as a cutting tool. Sedimentary rocks can be used in buildings, especially in making walls, such as the sandstones and limestones. Limestones can also be used in making steel and cement. This photo shows walls that are made up of sandstones. And this one is an example of cement that is made up of limestone. For the uses of metamorphic rocks, like slate, which can be used to make tiles for roofs. Here are some photos showing slate used as tiles for roofs. Another example of metamorphic rocks is marble. Marble is used commonly for buildings and sculptures. The good example of this is the Taj Mahal in India, which is completely made up of different types of marble. To sum it up, here's a chart showing the three main classification of rocks. Again, we have the igneous rocks, the sedimentary rocks, and the metamorphic rocks. Igneous rocks are formed from magma or lava. Sedimentary rocks can be formed from rock fragments that undergo sedimentary processes. And the metamorphic rocks are types of rocks that are formed from old rocks. Okay? And each type of rocks also has different types as well. Always remember that these types of rocks are classified by first, mode of their occurrence or where they were made. Second is based on their texture. And the third one is based on their mineral composition. And each type of rocks also exhibit many textures. And that's all for this lesson. Thank you for watching and listening. Keep safe, everyone.
Happy learning at home with lessons made easy by Olivarian GoTeach. One proud Olivarians.